2,955?
Yeah.
And how many million are we going to do that by?
5.
5 million. All right. Hey folks, welcome, and welcome out there to TNLearn Mathline. We're so glad you've tuned in this afternoon. I'm your host, Ernie Roberts, and today, it's not a call-in show day, it's specialized segments time, which means you get to sit back, relax, and let's do some math, enjoy. You really enjoy the math? Yeah, we're going to enjoy it. We'll learn a few things, all right? You never know what's going to pop up on a specialized segment, but it's always one specific topic, and we really go in depth with it, and that's what makes it a lot of fun. So thank you for tuning in this afternoon, and let's find out what today we're going to be doing on this show. Practice, practice, practice those 30, 60, 90 triangles. It's been a while since we've hit 30, 60, 90s, but it's always a good thing to come back to. So we're going to practice, practice, practice today. That's the plan. So, hey, you know what? When we go and practice, let's just get started, all right? Let's see what we got. Let's see our first problem, guys. It says, in a 30, 60, 90 triangle, if the shorter leg measures 24 inches, what are the measures of the two other sides? Let's refresh our memory. First of all, what does that 30, 60, 90 mean? Those are angle measures. So there is your 90, good old right angle hopping down there in the corner. We have a 30 right out here because that looks smaller to me. Actually, it is smaller. And then we got the 60 up here. Those are the degree measures, all right? So once we establish 30, 60, 90, I like to use 3 letters, A, B, and C. Now, C works really well because it's hypotenuse, all right? And we always think of A squared plus B squared equals C squared. Pythagorean theorem time. You got it, exactly. So where we're going to go is we're going to put A out here, and we're going to put B right there. And you say, Ernie, why'd you pick A and B where you did? Because A is going to be our smaller side, or smaller leg, I should say, because it's opposite to 30, which is the smallest angle of the triangle. B is going to be somewhere in the middle because 60 is, well, it's right between 30 and 90. Now, I will tell you this much. A, B, and C are not like, B is not like the average of A and C, all right? That's the first thing we've got to understand. B has a special relationship, and let's refresh our memories before we go into the final answers on these guys right here. So let's see. You thinking like I'm thinking? A is equal to 1/2 the hypotenuse. In other words, the shorter leg, that would be A, that's your shorter leg of the two, A and B are legs, all right, equals 1/2 the hypotenuse length, all right? That's the first relationship. Now, conversely, that tells me the hypotenuse is twice A, all right? Just as twice as big as A is, all right? Now, the relationship between B is a little funky because it's A times, actually, the square root of 3. Boy, that is somewhere quasi in the middle. It will create a length that is bigger than A, but not quite as big as C, all right? The hypotenuse has to be the largest or the longest length of the whole triangle. Now, keep that in mind because when you get your answers, you want to compare. Are they following that manner? In other words, is A smallest, B in the middle, C your largest length or your longest length, all right? So, oh, by the way, just in case you were wondering, how do we get to A? Well, we got to divide the square root of 3 into B. You say, what? So that's going to be B divided by the square root of 3. So we're going to look at these. This one's pretty easy, straightforward, because A is our starter because it says shorter leg, A. So we'll put our 24 right there. And remember what our rule says. We take to find B, which is the longer leg, right? The middle side, the middle length of the right triangle here, if you will. And we're going to get 24 times the square root of 3. Okay? And to get to C, oh my goodness, well, what do we got to do? We got to double 24, right? Because it says 2 times that. So that's going to give us 48. And all of these are inches, all right? Now, you know, we could have made that feet. We could have gone 2 feet. It'll be 2 roots of 3, 2 square roots of 3, if you will. And we got a 4, all right? And my goodness, they all work out, don't they? Now, real quickly, just for those of you who are wondering, what's happening when we multiply by that square root of 3? Let's take a quick look on the calculator, all right? And let's go there. We're going to take the square root, which means we go to second and we hit that x squared button, and it says, let's put a 3 in there. So what is this crazy factor we're multiplying or dividing by each time? Hit an enter. Well, there you have it. It's a little bit over 1 7/10, all right? And notice it rambles on and on. It is irrational out there, all right? It keeps going and going. That just happened to be when it rounded off and ran out of decimal places. So when we look at the square root of 3, It's like we're multiplying, we'll just say for round-off sake, we're taking 1 7/10 times that a value. So if you'll notice, our value is still going to be somewhat less than 48 on that. So that's what I want to make sure everybody's good with, and that's where we start, folks. That's our formulas. We're going to have to remember them. Today, guess what? The name of the show is Practice, Practice, and Practice. So let's do a little review. Let's go back over those radicals. It's been a while since we've tapped into them, so let's take a look at some radical multiplication. You say, well, Ernie, why are we worrying about this? Well, because there are going to be times, remember, by the formula for the 30, 60, 90s, we're going to multiply values, perhaps that are already in radical form, by the root of 3. That's real easy. If you got 24, you just attach the root of 3 and move on, all right? But when we've got something like this, we've got to think just a little bit about what's going on. Now, let's spell this out. I get a 6, and I have the roots. Remember, under the square roots, we multiply those two numbers together. So I'm going to have 6 times, what is it? The square root of 9, because that's what 3 times 3 gives me. Now, be very careful, my friends. The square root of 9, well, that's 3. Not a root of 3, just simply 3. So this is like saying 6 times 3, which will give me 18. Now, I really want us to start thinking a little bit here. When we take the root of 3 times the root of 3, my friends, we're going to always get 3. So there's no need in writing this root of 9, the square root of 9, and changing it around. When we take the square root of 3 times the square root of 3, it's the square root of 9, mental, all right, which gives you 3. So let's move this one rather quickly. All right, let's move this rather quickly. We've got 5, and there's a 1, by the way, in front of that. So that's why we're going to keep the 5. Did you say that? There's a 1 right there, just like there was. Oh, yeah, up here we had a 1 also. Okay, so that's easy to remember if that'll help you. And again, what do we say? Don't need to write down the square root of 9, right? What we're going to do is write times 3, because that's what we get. When we take a square root times itself, you get the number underneath it without the radical. By the way, radical is that little square root symbol that drives some of us crazy, all right? And by the way, final answer here, it looks like 15. Now, I'm hoping that some of you are going like, you know, Ernie, I think I can do that in my head. Of course you can. You can see 5, you can see the 3, you get 15. Move right on, all right? And in whatever units, we didn't start out with any specific units here, but that would be your case, all right? That would be what you're looking at. So let's go a little bit further here. How about it? We're going to say 4 times 2, that's 8. Let's see if we can do it mentally. I'll write it down anyway. Yeah, you say write it down. I've got an 8. We've got the square root of 3 times another square root of 3, which is like another 3 hopping in. Oh my goodness, look where we are. 24. Yes, we could have said 8 times 3 in our head and gone to 24 right off the bat. I want you to be able to do those kind of things, all right? I want you to be able to look at those roots when they match, those square roots when they match. That's a gift, okay? That saves us a little bit of time, effort, and certainly makes our numbers a lot nicer. So, quick review on multiplication. Let's see what happens when those radicals, those square roots, don't always come out to be a 3 there, all right? Let's take a look at our next set here. Got a few more. And we got to remember how to reduce a little bit. And once again, we're going to call on some mental math. The 4, remember there's like a 1 in front of that, all right? So the numbers on the outside of the radicals get multiplied together, and the numbers underneath the radicals get multiplied together. And since it's a square root times a square root, we're going to keep square root. All right, we're not going to change that. We're not going to change that. So by ruling here, we got 4, and I believe that's going to give us 2 times 3. That one's easy. 4 times the square root of 6. You say, are we done? We are done, all right, with this problem, because we can't break down 6 into any square roots times a number besides 1. Now 1 doesn't help us any. 1 times 6 just gives us the same thing. But if we can get a perfect square to divide into that number other than 1, then we can simplify. We can simplify. That's a big if. The only factors of 6 are 1, 2, 3, and 6, and none of those are perfect squares except for the 1. And like I said, 1 doesn't help us a bit. Let's take a look at our next situation. Once again, we got a 4 and a 1 on the outside. Pop that 4 right there. You go. And guess where we're going? We're going to say 6 times 3. And this time we're getting bigger numbers, aren't we, folks? 18. What do we do with 18? Are there any perfect squares lurking in the factors of 18? Well, I think there are, besides 1, in fact. I believe 9 times 2 is going to work for us. So here, refreshing your memory, and I hope your memory is good, we're going to break 18 down into 9 and 2. Right there we have it. Beautiful, isn't it? Now, this is a square, a perfect square. I can find the square root of 9. I cannot find the square root of 2 no matter how hard I try. It's irrational. It's going to ramble on and on. I can get an approximation, but you can't get the exact thing. So we're going to just worry about leaving that in form of a square root. But what do we do with the 3? What do we do with the 3? You said, well, the square root of 9 is 3. Yes. We got to bring it outside and multiply it into that 4. 4 times 3 gives us 12. How about it? 12 square roots of 2. And you've got it going. Not hard, is it? Now, think back a minute ago. We've got a 1 again. How about it? Let's see if we can do this mentally. We've got 5. Oh, you changed the roots, Ernie. Why did you make it 2? Well, I wanted to see if you could think beyond the roots of 3. Yeah. So let's see. We got 5 times 1. Keep that in mind. It's 5. What happens when we take the square root of a number times itself? In other words, the square root of 2 times the square root of 2. You come back to 2 because that's the square root of 4. All right? So there we go. 5 times 2. Can you do that mentally? Of course you can. I'm going to write it down just so everybody's with me. And there you are, 10. No root. Don't put a root of 2 on that. Because when you multiply the square root of 2 times the square root of 2, you get a nice rational 2. Not irrational, but rational 2. So be sure you keep that in mind. So that's a quick review of multiplication of radicals. Oh, there's a lot more to do with that. But for what we need today in our show, those are good enough. All right, so let's take a look now at division. Oh, division. Quick review of division, all right, because that's another thing we're going to worry about. Because remember on that formula thing, I said we're going to divide by the root of 3 at times when we're getting smaller, and we're going to multiply by the root of 3 when we get larger. Well, we just multiply by a lot of roots of 3. Let's go to some division here, all right, see what we've got. It's really sweet if we've got 6 roots. By the way, everybody remember fractions mean division? I just want to make sure everybody understands this is just writing fractions, and this means we're going to divide. And when we divide the square root of 3 into the square root of 3, they just cancel out. They give us 1, all right? And what's left is 6. That's easy. So in other words, if we give you a root of 3, a square root of 3, my friends, attached to some number for your b value, it's easy to get to the a and c. All we have to do is say, goodbye roots of 3, goodbye square roots of 3, and we're at 10. Right there we have it, all right? Now, let's see. On this one right here, a little bit different, I'm going to ask y'all, let's not take my picture out yet. Let's go to 15 divided by the square root of 3. What we got to do here is clean up. And how do we do that? Well, we have to rationalize. Ooh, we go, what did you just do, Ernie? We're reviewing, so I'm moving it fast, aren't I? We need to multiply to get the square root of 3 out of the denominator. How do we do that? We have to multiply it by itself because we cannot have irrational square root numbers in the denominator. So what good does that do? Well, let's find out and see. What it looks like to me, it gives us the square root of 3 times the square root of 2, which we know is 3. Isn't that so much nicer when you don't have to work through 3 times 3 is 9, all that good stuff? No, move right with it. Up on top, we have 15 times the square root of 3. Now, caution, very caution, because you can get all excited here, like I am, all right? And we can try to divide those 3 and square, but it doesn't work, all right? Because this one is outside of the square root radical. This one's underneath, so they don't mix. However, the 15 and the 5 are waiting to go somewhere if they can reduce. And know what we got here? We got 5 times the square root of 3. Because 3 divides into 15, bring that square root of 3 along for the ride, and you're done. That's your answer on that, all right? So let's see. Look what happened. I start with 15 divided by the square root of 3, and I end up with 5 square roots of 3. Let's see what happens on this 24, and let's see if we can do this other one up here mentally, and we'll lose my picture at that point, all right? So let's see. Multiplying, want to go through it? Let's do our routine. We got to multiply by the square root of 3. Now, by the way, why do we have to do it? Because we're multiplying by 1, folks. So we've got to put another square root of 3 into the numerator, just like we did in the denominator. Now, I'm seeing, you're seeing, we all see, there's a 3 now with no radical, right? Everybody got that little moment down? The square root of 3 times the square root of 3, bang, it's gone. And don't keep writing 9s down because it's not going to change. It's going to stay the same. And let's see, I have a 24 times the square root of 3. 3 divides into 24. That's sweet. And you know what? We get 8 square roots of 3. So there's your final answer there. Now, do you see what's going on? I'm going to throw you a little rule called divide and attach. In other words, if you will divide that 3 into the 24, or in this case 3 into 15, you're going to get a number that comes out nice and even because those are multiples of 3. Now, if they aren't multiples of 3, we'll deal with that in a minute, all right? But we can divide, and then we attach the root. So look what happened. We divided 3 into 15, got 5, brought the root up, attached it, 5 roots of 3, 5 square roots of 3. Isn't that amazing? How about this next one here? You've got 24. Let's divide it by 3. That gives us 8. Bring the square root of 3 up, 8 roots of 3, or 8 square roots of 3. And as I say here, that's where we're going. That's where we're going. So take a look at this one. Let's do the divide and attach rule, and they're going to probably throw my picture out here for just a second. Say 21 divided by 3, you get 7, all right? And bring the root of 3, that square root of 3 along for the fun. You got it, 7 times the square root of 3. Now, some of you are going like, well, Ernie, is the last one here, is this going to be, what are we going to do with that? Well, we're going to divide 3 into 7. It doesn't go evenly. So we're going to write that as 7 thirds, 7 over 3, 7 divided by 3, however you want to do it. And let's bring the square root of 3 up for the ride, and there you go. So even if they don't come out even, just make an improper fraction and move on, okay? When they come out even, enjoy, love them, okay? But let's see, now let's apply this little divide and attach rule to some problems, all right? Can we move on here? Thank you. All right, let's take a look at our next problem here. In a 30, 60, 90 triangle, if the shorter measure of the shorter leg measures 9 roots of 3, we'll get that out, and these are inches. So in other words, here we go. There's the 90, there's the 30, there's the 60. I will always put those in there because it's nice to know those things. Remember what I've used? I've used the letter A opposite the 30 because it's the smallest. B in the middle, it will be our opposite the 60. And then finally, hypotenuse is always the longest side of a right triangle, all right? So with those things in mind, what are we starting with? We're starting with a shorter leg, but we've got a crazy little thing called 9 times the square root of 3. Now remember our story. Where formula says B is equal to A times the square root of 3. Now, when my students have struggled with these, once they get over this little bump right here, it's usually fairly simple to work with. But you've got to remember, we have been given 9 times the square root of 3 for our A. Plop that right in there for A. And you've still got the square root of 3 to bring along for the ride. Now, guess what? It looks like problems we just practiced, didn't it? We'll bring the 9 over. Oh, what's the square root of 3 times the square root of 3? It's 3. So our final value for B is 9 times 3, which gives us 27. Now, I am hoping that you're starting to see this relationship going here, that if you've got the root of 3, the square root of 3 here, when you multiply another square root, you're just going to be multiplying 9 times 3 and you're done. You don't have to go through all this if you know your formula. Yeah. Now, what's easy? C. Remember, C equals what? 2 times our value of A. A is 9 times the square root of 3, double that. And you're going to get, well, you're going to get 2 times that 9 times the square root of 3, or 9 square roots of 3. And you know what? That equals 18. And bring the root, that root along for the ride. So 18 square roots of 3, that's your final answer for C. And notice we lost the radical on B. That's okay. That's okay. A and C have the roots of 3, those square root of 3 radicals there. And the B, absolutely nothing in the middle. All right, so careful is as careful does. And again, it's pretty straightforward. Let's take a quick look at our next one here. See if we can work through this even faster. 30, boom. 90, boom. 60, there we are. All right, those are degrees, by the way. All right, so there we go. That was a little bit larger, and this one is boxed off. All right, so 3 different angles running through this thing. Where are we starting this time? We're starting with a hypotenuse. 30, 60, 90. We've got a hypotenuse measuring 16 square roots of 3. And by the way, these are meters, so everything's going to be in meters, just like the other one was in, inches, so everything will be in inches like we had before. So in case some of you are really into making sure those units of measure jive, and it's a good thing. It's a good thing. They're all staying the same. We're not working with areas here. We're keeping the same length throughout. Now, it says, what are the measure of 2 legs? Let's go for the small one. You know why I go to the small one? Because it's easy. Remember a formula. A is equal to 1/2 of C. So we're going to half 16. Keep the square root of 3. Don't get nervous. We don't have to take half of the square root. That's the good news. And we're going to have, looks like our A value is right here, 8 times the square root of 3. There you have it. Now, let's go back to B again. B says we're going to take A times that square root of 3. If A is 8 roots of 3, remember what we were thinking, keep the 8. Multiply square root of 3 times the square root of 3, you get 3. Mental math time, all right? What do we got? 8 times 3, exactly, which equals 24. By the way, these are all lovely meters. Meters, 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 all right? And you got it. So easy. So easy. That's why we practice because we start seeing connections and we start saying, hey, we can do a lot of this in our head. Yes, we can. Once you get the routine down, it becomes very, very sweet and easy to get through 30, 60, 90 degree triangles. So let's see. Practice makes perfect. Remember what I said. Let's go a couple more here. Let's start from the longer leg this time. Oh my goodness, all right? So we're going to put a 4 times our square root of 3 right there. You say it's longer? Sure. There's the 60, there's the 30. Life is good. And remember what happens when we divide this value by, oh my goodness, because it's how we get to A, isn't it? A equals that B divided by the square root of 3. We'll put it right in there. And you've got 4 times the square root of 3 divided by that square root of 3, blah, blah, blah. Say goodbye to those square roots of 3. They're gone. You got a 4. Oh, it's easy. Oh, it's easy. And by the way, that's A. That is your A value. C's the hypotenuse, right? Yes, yes, it is. Hey, you already got the answer out there, I'm sure. It equals 8. How quick was that? Know your formulas. Right, there we go. By the way, you say, Ernie, how did you get there again? C, remember, is 2 times A. And this was your other little formula. How do you get to A from B? You divide because it's getting smaller. If you want to go from A to B, you multiply. It's getting larger. All right, and it's always about the root of 3. Always about that lovely square root of 3. All right, let's take a look real quickly at another one here. Shooting this one out. We got a 90. We got a 60, and my goodness, we got 30 right there, okay? What do you know? It says if the longer leg measures 18. So that's B. Oh, we're starting with 18. It doesn't have a root on it. Doesn't have a square root on it. Uh-oh. And over here, we've got A, which is typical, and we've got C, hypotenuse. So let's go for A. And let's see if we can use that divide and attach rule I taught you a little bit earlier. We have B equaling, what? No, B equals what? A root times the square root of 3, right? But that's not what we need to use here. We need to go backwards, right? Because we're going for the smaller piece. So we've got to go back to A equaling B divided by the square root of 3. So put your 18 right in there over the square root of 3. Let's divide and attach. Let's have fun with it. Oh, my goodness. Goes in there 6 times, right? Bring the square root of 3 along for the ride. You have your A value. Right there it is, all right? So it's a 6 times the square root of 3. We'll put feet on that, all right? This is feet. Double it. Double it. How easy is that? Double 6. You get 12. And bring the square root of 3 and the feet along for the ride. There are your 2 remaining sides. How quickly can we do some problems? What do you think? It's almost the end of the show. Let's go for it. Let's see what we got here. Let's take a look. Let's complete this table as far as we can go. Whew, let's go. All right, first one's easy. Rules, remember, by the way. Yeah, B equals A times square root of 3. C is equal to 2A. That's where we work the first few. All right, first few parts. Let's do it mentally. Bring, oh my goodness, just put 4 times the square root of 3. Right there it is. That was straightforward. Double the 4, you're at 8. I don't care what the units are. That's what your numbers are going to be. All right, you can attach units later. We've got 7 times the square root of 3. Let's multiply it by the square root of 3. That's going to push us to, what, 7 times 3, which is 21. And then double A, you're going to have 14 times the square root of 3, or 14 square roots of 3. And that's a 14, by the way, all right? Kick it here. Let's lose the square root of 3. We'll work backwards. Divide by the square root of 3, and oh my goodness, we're at 3. And we're at 6. Double it. That's quick. Here, divide and attach. Remember, you're going to divide. Remember, A equals B divided by that square root of 3. So divide and attach. It goes 10 times. 30 divided by 3 is 10. Bring the root of 3, that square root of 3, right up there. There you go. Double it. It's time to double for C. I bet y'all are going like, man, I can't believe we're going to do this so fast. It is so easy, though. It is so easy. Let's kick this one out. Divide 6 by the square root of 3. You're going to have 6 divided by 3, 2. Put that square root of 3 right there. Double us. 4 square roots of 3. My goodness, how easy. And the last one, I gave you a freebie. I really gave everybody a freebie on this one, all right? So we've got 20, and we're going to take half. That gives us 10. And then bring your square root of 3 right along. And folks, woohoo! Easy. Is it not? That's easy, right? Yeah. Hey, thanks for tuning in today. We've had a great time, I hope, on this 30, 60, 90, and I hope it helps you. You can slow this, if you've DVR'd this thing, you can slow it down, you can speed it up however you want, but I hope you get to use it and practice it a little bit. We've enjoyed having you with here, Specialized Segments. You know what? We're going to be back next time live again.